This video is about calculations involving acids and bases. So the key word is dissociation of water is an endothermic reaction. The question's also asking about water at 40 degrees Celsius. And we can look at the answer options to give us a clue of what to look for. So we have concentration of H plus and OH negative, as well as pH. So the concept of this question is the effective temperature on the pH scale. So let's look at a pH scale. So we know that the pH of 7, it's where it is neutral. And if we were to increase this pH up to 14, it gets more basic. And if we were to decrease pH down to 1, it becomes very acidic. But this only applies when the temperature is at room temperature, which is 25 degrees Celsius. If we were to be more technical about it, pH is actually the measure of the concentration of H+. The pH of 7 doesn't necessarily mean the solution is neutral. It means there is 1 times 10 to the power of negative 7 of H+. Let's look at a dissociation equation of water. So we have water dissociating into H plus and OH negative. And remember, this is an endothermic reaction, so there is heat on the reactant side. If we were to have an increase in temperature, heat would increases, and the equilibrium will shift to the right. And we would have an increase in the products. And remember, the relationship of pH and H plus concentration is pH equal to the negative log of H plus concentration. So if H plus concentration were to increase, the pH would decrease. Different scenario where we have a decrease in temperature, the equilibrium would actually shift to the left. So there is a decrease in products. And so again, if we were to look at the same relationship, if H plus concentration were to decrease, then pH increases. If we were to go back to the question, remember this is an endothermic reaction, so heat is on the reactant side. And we have an increase in temperature. And so the equilibrium will shift to the right, and the concentration of H plus increases. So the answer is C, as pH will decreases.